So, have you ever just looked up at the night sky and wondered, how did all of this begin? Not just us, not just our planet, but literally everything. Well, today, we're putting on our detective hats. We're going to dive into one of the greatest cosmic mysteries ever solved, the story of the Big Bang.
Okay, so let's kick things off with a fantastic bit of irony. You know the name Big Bang? Well, the guy who came up with it, astronomer Fred Hoyle, absolutely hated the idea. He actually coined the term back in 1949 on a BBC radio show, and he meant it as an insult. He was trying to push his own theory of a steady-state universe, one that was just always there, no beginning, no end.
But what if he was totally wrong? What if that nickname, the one he meant as a joke, actually turned out to be the perfect description for one of the biggest scientific discoveries of all time? What if all the evidence was pointing to something that Hoyle and others just couldn't wrap their heads around? The idea that our universe actually did have a beginning.
All right, so let's start unraveling this cosmic mystery. Our story doesn't begin at the dawn of time, though. Nope. It starts much closer to home, back in the early 20th century, when astronomers started pointing these amazing new telescopes up at the sky and found something really, really weird.
So here was the big puzzle, the question that was bugging everyone. Why does it look like everything is running away from us? I mean, almost every single galaxy they could see was just zooming away. It made it seem like we were at the very center of a massive explosion. But that can't be right, can it? Are we really the center of the entire universe?
And then, in 1929, we get our first huge clue thanks to Edwin Hubble. He discovered something incredible. It wasn't just random. There was a rule. The farther away a galaxy is, the faster it's flying away from us. Think about it like this. Imagine you're baking raisin bread. As the dough rises, all the raisins move away from each other. From the perspective of any single raisin, it looks like all the other raisins are moving away. That's what's happening. It's not that the galaxies are flying through space, it's that space itself is expanding.
So, if everything's expanding, moving apart, what happens if you hit rewind? I mean, just run that whole movie backwards. Everything would get closer and closer and closer together. And that simple, logical step led to a truly wild idea.
This is where Georges Lemaitre, a Belgian physicist and priest, comes into the picture. Way back in 1931, he took that rewind idea all the way. He basically said, okay, what if we rewind it to the very, very beginning? He proposed that the entire universe, everything we see, must have started from a single, super hot, super dense point. He called it the primeval atom.
And that really set the stage for a huge scientific showdown. In one corner, you've got the steady-state theory. The universe has always been here, always will be, and new stuff is just kind of popping into existence to fill the gaps as it expands. And in the other corner, you have this radical Big Bang idea, a universe that had a birthday, a single starting moment, and has been expanding and cooling down ever since.
So how do you solve a debate like that? You need a smoking gun. You need hard evidence. And in 1964, that's exactly what two astronomers found, completely by accident.
Picture this. Two guys, Arno Penzias and Robert Wilson, are working with this massive radio antenna, and they keep getting this annoying hiss in their data, a constant background noise. They tried everything to get rid of it. They checked all the electronics. They even, and this is a true story, cleaned out pigeon droppings from inside the antenna, thinking that might be it. But the hiss was still there. No matter where they pointed it, day or night, it was coming from everywhere.
What they had stumbled upon was incredible. It was the cosmic microwave background. It was literally the echo, the afterglow of the Big Bang itself. See, for the first few 100,000 years, the universe was this super hot, dense soup, a fog of plasma. You couldn't see through it. But then, it cooled down just enough for atoms to form, and suddenly, the universe became transparent. The light that was trapped in that fog was finally set free, and it's been traveling across the cosmos ever since. That faint hiss, that was it, the oldest light in the universe.
And the temperature of that ancient light today? It's incredibly cold, just 2.725 Kelvin. That's barely above absolute zero. But here's the absolute kicker, the thing that blew everyone away. Scientists who backed the Big Bang Theory had already done the math. They had predicted that this afterglow should exist, and they had even calculated what its temperature should be now. And Penzias and Wilson's discovery? It was a perfect match. It was the ultimate proof of a universe that started off hot and has been cooling down ever since.
Okay, so that cosmic afterglow was a huge deal, a game changer. But the Big Bang Theory didn't just make one prediction, it made several.
And the next one was all about the universe's very first recipe, what it was made of.
See, the physics of the Big Bang was incredibly specific. It predicted that in the first few minutes, when the universe was like a giant nuclear furnace, it should have cooked up the lightest elements in a very specific ratio. About 3/4 hydrogen, about 1/4 helium, and just a tiny pinch of other light stuff. And guess what? When we look out at the oldest parts of the universe, at the gas clouds that haven't changed much since the beginning, that is exactly the recipe we find. Another perfect score for the Big Bang.
Okay, so we've got the clues, we have an expanding universe, we have the echo of creation, we have the universe's original recipe. All the evidence points in one direction. So now we can actually tell the story. We can build a timeline of the universe, from moment one all the way to today.
All right, let's do a quick fast forward through 13.8 billion years. Ready? In the very first sliver of a second, the universe undergoes this insane growth spurt called inflation, going from subatomic to huge in an instant. By the 3-minute mark, the first elements are cooked, mostly hydrogen and helium. Fast forward to 380,000 years, and that's when the cosmic fog clears and the afterglow, the CMB, is released. It takes about 1 billion years for gravity to start doing its thing, pulling all that stuff together to form the first stars and galaxies. And then, about 9 billion years in, something strange happens. The expansion starts to speed up, pushed along by a mysterious force we now call dark energy. And that brings us pretty much to today.
Look, the Big Bang Theory is one of the most successful ideas in all of science. It's a monumental achievement. But here's the thing about science. Every time you answer a big question, you uncover a bunch of new, even bigger ones. This story is definitely not over yet. I mean, think about it. What is dark energy? The stuff that's making the universe expand faster and faster. And what about dark matter? This invisible stuff that seems to make up most of the mass in the universe and holds galaxies together. Why is there something instead of nothing? Why did matter beat out antimatter in the very beginning? And of course, the biggest question of all, what, if anything, came before the Big Bang?
And that leads us to one last thought. And this one is a real mind-bender. Some of the latest theories, things like eternal inflation, suggest that maybe, just maybe, our Big Bang wasn't the only one. Maybe our entire universe is just one bubble in a vast cosmic foam of other universes, a multiverse. So what if we've solved the origin of our universe, only to find out we're just a tiny piece of a much, much bigger and weirder cosmic story? That's where science is headed next. Pretty wild, right?